right, welcome back, guys. Thank you for watching yet another video. Today, our topic of discussion will be limits at infinity. Okay, so ideally, what we're doing is this time we are making x approach whether it is infinity or negative infinity. So, in other words, what you're actually exploring is the idea of end behavior of a function. So, in other words, as x gets very large or x gets very small, what does the function behavior do? Does the y value go to a specific number? Does it go upwards to infinity, downwards to negative infinity? Cool. So while I bring that up, is some of this stuff you have already done, hopefully, in previous courses. You just never thought of it as a limit per se. So one of those examples that I can think of is the idea of a polynomial. So for example, go with example number 1. If I have the limit as x approaches infinity of x to the power of 4 plus 3x minus 1. Okay? So first things first is from pre-calculus, hopefully you remember this is a polynomial. And a polynomial is a function that is continuous and smooth. Now, back in pre-calculus, hopefully you were taught how to figure out the end behavior, so I'm going to go ahead and use that. The way that you would do this is you would have to analyze what the power is, which in this case is even. And if you remember, or if you don't, hopefully, I'll give you a little note here. If you had an even power, this is for polynomials, by the way, your end behavior would either be going up in both directions or down in both directions. And that had to do with whatever was happening at the front, whether it's positive or negative, okay? If it was positive, you would be going up in both directions. And if it was negative, you would be going down in both directions. Cool? Well, in this case, I have a power that is even with a positive leading coefficient, which means the graph towards the right is gonna go up, towards the left is gonna go up. In this case, I am interested in an x going to infinity, which is the right side. Therefore, this would be going to infinity. Okay? Now, if for some reason you had something, and let's just try another example, x approaches negative infinity, let's go with a negative x cubed plus 2x squared minus 3, something like that, okay? This time, you have an odd power, so odd power. If you had an odd power, you could do one or two things. It would either be going down and then up, or up and then down. And again, it depended on what symbol you had here. If it was positive, it would look like this, where it would be falling down on the left and going up on the right. And if it was negative, it would be going up on the left and then down on the right. In this case, I have a negative odd power. Therefore, according to the rules, I will be going upwards towards infinity. Okay? So that'll be using rules that you learned in back in pre-calculus, hopefully. But realistically, I mean, the other way to kind of look at it sometimes, I don't love this analysis, but you can kind of try to reason this out. Hypothetically, let's go back to example 1. You had a very large number, you took it to the 4th power, that is going to be a very, 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 very large number. Cool. And then it's like, I would almost call it like infinity, right? Obviously. And then if I have infinity times 3 is infinity, and then minus 1. Now, this is where you got to be careful, because the size of this infinity versus the size of that infinity is not the same, right? Now, in this case, it's not going to matter too much, because if you take a large number and you add a very large number, and then you subtract 1, it's not going to make much of a difference. So you should be kind of analyzing towards infinity. So you just got to be careful. What I'm talking about is, let's say, let me switch this. No, actually, I like this example. So like if I was going to do that kind of analysis here, let's say if I had a negative, very large number to the 3rd power, is going to stay very negative, but then I had the negative, so it's going to become positive. Cool? All right, so then let me switch this so that it can make sense. So now, if I have a negative value that is square, and then I multiply it by a negative 2, it's going to become negative, very large number, okay? And this is what I'm trying to talk about. You got to be very careful how you approach, if you're going to approach them in this direction. Because you're going to be tempted to say, well, this number minus this number, well, they're going to cancel because infinities are the same, and that's not quite true. You can't treat infinity as a number per se, and that's why this analysis, that's what you're trying to do. You're trying to treat infinity as a number, and infinity is not a number, so it doesn't really behave in the way that numbers do. But if you're still wanting to do this analysis, you just have to remember, this is a much larger infinity than this one. So when you take away a smaller infinity, technically you're still, like, again, I don't love this analysis, but technically you're still living with a very large number, and taking 3 away is not really gonna make a difference. That's why I'm ending up with infinity. I would suggest against that type of analysis, but you are welcome to utilize it. I like more knowing it, specifically if it is a polynomial, knowing these rules so that you can get to an answer with more certainty. Okay? All right. Let's try another example. Maybe not a polynomial. Let's see what I got here in my notes. I got something like, what is the limit as x approaches infinity of e to the power of negative x? Okay, so this is where I would say I would personally rely a little bit more on like my graphing abilities from, again, pre-calculus. What does e to the negative x look like? Okay, so one thing to remember is an exponential function has a horizontal asymptote at 0. Cool. In this case, if you kind of forgot what this looks like, you can very quickly put in some values so you can kind of come up with a graph. But substituting 0, e to the power of 0 would be 1, which would put me here. And then if I put in like, let's go with a -1, so I can make this into a 1. -1 would produce e to the first power, which is just e, so that'll be maybe about here. So now, what I do know is this is gonna go up, and this is gonna go in this direction. So based on this graph, just by looking at it, as x is going to infinity, I can certainly see that it's approaching a specific value, which is my asymptote, which in this case would have to be 0. Okay? Another way to look at this problem is maybe you can rewrite it as the limit as x approaches infinity of 1 over e to the x using the exponent rules you've learned back in algebra. Okay? And you can do a little bit of the analysis, kind of like very similar to what we did here, except this time I do tend to feel a little more comfortable, at least with this analysis I'm going to do. So hopefully you agree with me. If I put an infinity here, when I do e to the power of infinity, that's going to create a very, very large number. Cool? So now let's pretend I have, like, let's think of money. Like I have $1, and first I split it into 2 people, so that everybody gets 50 cents, and then 3 people, 33 cents, and then 4 people, 25 cents, 5 people, 20 cents, 10 people, 20 people. What I'm starting to see is that I'm getting less and less and less and less. So the larger the numbers on the bottom, the less I get. Now remember, a limit is not about what are you getting, but it is about what you're approaching. The larger in magnitude the number in the denominator, the closer and closer you arrive at 0. So that will be another way you can kind of utilize some kind of number analysis. Okay. Now, if, for example, I had the same problem, but let's say we were going to negative infinity instead. So if I had the limit as x approaches negative infinity of e to the negative x, well, with the graph, right? I got the graph. I can simply just observe that it is going to infinity, right? But again, let's say you wanted to do an analysis similar to this. We can say the limit as x approaches negative infinity. This time I actually don't need to rewrite it, because if I do e to the negative power of x, which is by substitution, then let me erase this because I'm actually kind of taking the limit. I'm going to treat it almost as like this, like I'm substituting in. Then it creates this idea of e to the infinity, which would be a very large number. So therefore, I can say that the limit is just going towards infinity. Okay? So my point with these first 2 examples is that your knowledge of pre-calculus can really help you arrive at the end behavior of a function, and it all depends on how much you remember. I'm a big advocate of saying that it's not really the calculus sometimes that students don't understand. What really ends up coming to bite you is your lack of or shakiness of your algebra. Okay? All right, so I'm going to go ahead and erase this. Give me just a minute and we'll try a couple more examples. All right, and we're back. So we got 2 more examples. Let me kind of zoom in a little bit here. This time, as you can see, we are going to be dealing with rational functions. So before I even start this, remember, the idea of limits and infinities, that we want to figure out what the end behavior is doing. So if you go back to your pre-cal days and you're trying to think of like, okay, what is the behavior of rational functions? And you had to hopefully remember that rational functions are typically dealing with asymptotes. And by definition, an asymptote is something that I approach very closely forever, and in this case, towards infinity. So that's going to be the key to this problem. If we can figure out, in this case, if we have horizontal asymptotes or slant asymptotes, then we can actually figure out my behavior without really having to do any type of numerical analysis, okay? So, quick reminder, the way to figure out what type of asymptotes you have has to do by comparing the degrees of the highest term, which in this case, let's look at example 3. I am looking at a square versus a third power. Now, if your numerator, which in this case is 2, is less than the power of your denominator, you automatically have a horizontal asymptote at y equals 0. Okay, so without me even having to graph this, if my asymptote horizontally is 0, and by definition an asymptote is something that I approach forever, then that means that as I go to infinity, I would have to go to 0. That's simple. Okay, now let's look at this one. This time I have a cube on the numerator and a square on the denominator, which means in this case we have the numerator being larger than the denominator. Well, in that case, you actually don't have a horizontal asymptote. You have something called a slant asymptote, and that would be located at y is equal to, you have to divide whatever the actual division is. So you're gonna have to take some time to do this. So let's go ahead and do a little bit of division here, nothing crazy. So we have 4x cubed minus 2x squared plus 4x minus 7 divided by negative 2x squared plus 5x minus 9. Okay, remember to divide, we got to focus on the first term of each, the dividend and the divisor. So 4 divided by negative 2 would be negative 2, and then x cubed divided by x squared, I would need an x. So that would give me negative 2x. When I multiply this out, I will get positive 4x cubed, and then I will get a negative 10x squared. And then lastly, I will get a positive 18x. We will do our subtraction. This term has to cancel. In this case, this 10 becomes a plus, so that will be an 8x squared. This will become a negative, so this will be negative 14x. I will bring down the 7. But here's the thing I'm going to do. I know then that for this one, I have a slant asymptote at y equals negative 2x plus or minus something. And I really don't care what that is, because at the end of the day, the slant asymptote, if it's starting to look like this, whether I'm adding or subtracting anything, what's going to happen is that it's going to be linear. So if I were to kind of graph this, I'm like, okay, negative 2x, that's going to be a line that looks like that as an asymptote. Remember, by definition, I'm supposed to follow this asymptote. Okay, I'm sorry, that was a little too close. All I got to do is, okay, as I'm approaching negative infinity, which is in this direction, this is going to follow this asymptote, therefore it is going to go towards infinity. Okay, so notice, I mean, I said there wasn't going to be a lot of algebra, but at least for this one there was a little bit. But if you know your rules of asymptotes, you can quickly figure out the answer, okay? I don't have an example for it, but what happens, well, I can make one up. Let's do that one real quick. So let's do the limit as x approaches negative infinity of 3x squared plus 1 over 2x squared minus 7. So, as you can see this time, you have powers that's 2 versus 2, so in this case, they are the same. So when the powers are the same, you're going to have a horizontal asymptote at y is equal to a divided by b. And your question should be, well, what is a and what is b? A and b are going to be your leading coefficients. So in this case, I have 3 and 2. Therefore, when I divide them, 3 divided by 2 is 3 halves, which means I will be going towards 3 halves because I have a horizontal asymptote at 3 halves. Cool? All right. To me, this would be the most efficient way to approach this. However, I like to give you options. So there is another way to do this. So let me kind of erase a little bit here so I can have some space and show you what that other method is. Okay? So we'll go ahead and start with this one where I have more space. Okay? Let's get rid of this. Let's get rid of this. Okay. Here's a technique that I believe is pretty useful. So, according to your rules of algebra, specifically with a fraction, if you divide the denominator by something, as long as you do it to the numerator, it balances it out. So, what I'm going to do is I'm going to find the highest degree term on the denominator, which in this case is an x squared. And what I'm going to do is I'm going to divide everything by x squared to balance it out. So what's going to happen is I'm going to take this and divide it by x squared, and then all of this and divide it by x squared. And I'm going to clean that up. So that will become the limit as x approaches negative infinity. and I would have 4x cubed over x squared minus 2x squared over x squared plus 4x over x squared minus 7 over x squared over negative 2x squared over x squared plus 5x over x squared minus 9 over x squared. And I'm going to simplify, okay? Notice that I keep writing the word limit because I have not taken the limit, okay? So the limit as x approaches negative infinity, 4x cubed divided by x squared will leave you with a 4x. 2x squared divided by x squared will leave you with a 2. 4x over x squared will give you a 4 over x. And then this doesn't simplify, it will stay at 7 over x squared. In this case, I would have a negative 2. 5x over x squared leaves me with a 5 over x. And then the last one does not simplify, okay? So now, why am I bringing this up? Let me clean that symbol up. Is if you wanted to do kind of like the numerical analysis, you can kind of substitute, and remember by properties of limits, you can substitute each one individually and see what happens. So ideally what's happening is, let's say I put in a negative infinity into this problem right here, this specific part. So I would have negative infinity times 4, that just creates a very large number in the negative direction, okay? All right. We know that the limit of just the constant itself, no matter what I'm approaching, will always be the constant, so that will be minus 2, okay? We did this analysis at the beginning. If I have 4 and I divide it by a very, very large number, I would be approaching 0. That will be the same analysis here. That will be the same analysis here in the back. Same analysis here because I'm dividing by a very large number. And then lastly, the limit of a constant is a constant. Okay. So if I do a little bit of numerical analysis, I know that if I have a very large negative number and I take away a very, like just 2, it's still going to be very negative. So I essentially have a negative infinity divided by a negative 2. The fact that I'm dividing two negatives gives me a positive, and taking a very, very large number and dividing by 2 is not really going to make a difference, resulting in infinity. So as you can see, I still land at the same location as where I did just the simple shortcut of finding this line to asymptote, okay? I don't hate this method, but again, this method relies on you being very, very, very careful and remembering that when you are dealing with infinity and you're treating it as a number, you have to be very careful, okay? Remember that when you multiply or when you take it to a power, it creates different magnitudes of infinity. So if you feel like you're capable of doing that, this could definitely be a strategy that you can definitely utilize for you to figure out limits at infinity, okay? All right, I think I have one more example to show you before we call it a day. So give me just a moment. I'm gonna go ahead and erase the board and then we'll move on. All right, and we're back. Okay, so actually I lied. I have 2 more examples just so you can feel a little bit more comfortable. So let me zoom in a little bit. So the first one is this one with a square root. They actually have a square root. So I wanted to talk about that because it's typically one of the things that a lot of students get stumped on a lot, okay? So let's first look at the graph. So I actually use decimals here to help me out. I'm gonna zoom out and show you what the graph of that very first one looks like. So the one with the square root of 11, okay? So the very first thing I would want you to analyze is, it seems like there's this asymptotes here in 2 locations. So let me go to the board and show you where they're at. It seems like there is an asymptote here. And then it seems like there's an asymptote maybe here. So on the right side and the left side, it seems like I'm approaching different things. So in this problem, since I was asking you about what am I approaching from negative infinity, then I should be wondering like, okay, what is this value? So let me show you how to figure that out, okay? So let's go back to the problem here on the board. And the fact that this is a rational function makes me think of, well, I should be able to compare powers, okay? Now, some students get a little bit tripped up about what I'm about to show you because it kind of breaks what you know about square roots. But remember, when I am comparing a rational function, all I really care about is the highest degree term. So it's like I'm going to ignore all of this, and I'm only going to focus on this. Now, the degree in here is 3. And then technically speaking, guys, if I have the square root of 11 x to the 6, I can turn this into plus or minus the square root of 11 and then x to the 3rd. Cool. Which then at that point tells me, well, wait a second, that means that the degrees are the same. So according to what we said earlier, I would have a horizontal asymptote at y equals dividing the coefficients, which in this case is -2. Now here's the tricky part. I get this plus or minus root 11. Okay, let's go back to the graph. That makes sense, because if I do -2 plus or minus, not 11, I'm sorry, root 11, that is actually producing two solutions, -2 root 11, and then +2 root 11. Okay, so as you can see, that's actually producing two asymptotes. Cool. I don't even have to check, but I can if you want to. But I said essentially this would be y is equal to 2 square roots of 11, and this would be equal to y is equal to -2 square root of 11. Okay, so since I have the graph, now that I know where the asymptotes are, now I can 100% be like, okay, I am going towards 2 over root 11, or if you really want to rationalize that, 2 root 11 over 11. Okay, so I guess your question should be at this point. Let's go back to here. What if I don't have a way of graphing this? How could I tell which one to do? Okay, so here's my advice. Okay, so I'll put this down here. Okay, if you're approaching negative infinity, okay, when you take the square root of whatever's happening here, I want you to keep the negative value of whatever the square root is. And if you are going towards infinity of whatever the square root is, I want you to keep the positive value of that square root. So if I go back to this one, if I was doing it without using the graph, I would say, okay, I'm getting plus or minus, right? Now, the fact that it's approaching negative, that would mean, okay, the top definitely keeps the -2, and then the bottom, as I go into infinity, I'm going to keep the negative root of 11. So when I divide the negatives, I would stay with 2 root 11, which 100% agrees with the graph. Cool? Pretty simple, okay? It's just one more extra step when you're dealing with roots. So let's do one more. So for this one, I'm like, okay, I got a limit as x approaches infinity. Technically, I'm going to focus on these two numbers here. So I have 4x versus the square root of 9x squared. If I simplify that, the square root of 9 is plus or minus 3, and then the square root of x squared is x. So I have first degree versus first degree. So that means I should have a horizontal asymptote at y is equal to dividing the coefficients, which is 4, and then plus or minus 3. Now, since this is going towards infinity, I'm going to keep the positive solution. So that will be y is equal to 4/3, which means my solution to this is 4/3. Cool? So let's use the graph to confirm it. So I went ahead and put it on decimal. So let me go ahead and go back to the screen and then switch to the other graph. And make sure that it does agree with what I'm saying. According to what I was asking is, as I go to infinity, it definitely looks like I am going towards a positive value. Judging from this, here's 1, here's 2, this definitely looks like 4/3. Okay? All right. I think that'll be it for today. Hopefully you understand most of the problems that you will be dealing with in this section would have to do with rational functions. So I definitely suggest that if you do not remember, you go back and try to review how to figure out horizontal asymptotes and slant asymptotes. However, I hope that the other technique that I gave you to approach this in a numerical sense could also be beneficial, just in case you get stuck on a problem. Cool? All right. Well, thank you for watching. I appreciate you guys being here, and we'll see you next time. Take care.